Alright, so here we are in chapter 3.2 once again. 3.2, we're talking about concepts 3.2 for intermediate algebra, college algebra. Talking about this slide was section 3.2a and 3.2b, talking about moving the growth factor from 20 minutes to 1 hour or 5 hours to 1 hour. Look at those videos from 3.2a or b if you want. Here's 3.2c talking about compound interest formula. In general, a compound interest formula is going to be of this form. A of t equals p times 1 plus r over n to the n-th power. So what does all this mean? Well, here's our variables. P basically is the meaning for that is principal. Principal, that's basically our starting amount. The amount of money that you would take to the bank or that you would borrow from the bank. Usually take it to the bank and say I want to invest that. That would be the principal, the starting amount. R should be a small r actually. R is the interest rate in decimal form. Decimal form. N should be a small n, I guess, according to our formula here. N is the number of times that the interest is compounded or interest is calculated. Hang on a second. Interest is compounded in 1 year. We're going to get to that in just a second. In 1 year. In 1 year. T is time in years. Has to be in years. A of t gives you actually the amount of money in the account after t years. So it takes into account, number one, the principal that you started with and the compounding as well. So basically that's all we've got. There's our variables p and r and n and t and a of t. This one, if we're comparing to basic interest or simple interest, simple interest gave us just simple interest was I equals p times r times t, principal times rate times time, and that was just simply the amount of interest that you got after a certain amount of time. This a of t gives us the total amount of money in the account, including principal and interest. So that includes both principal and interest. Time, nothing new there. Principal, nothing new there. Rate, nothing new there. N is probably the new one that really we have to kind of concentrate on. So N just simply talks about the number of times that that we've compounded. So N, let's see, if N is 1, then the number of times that we compound in a year, compound in a year's time is 1. If n is 2, we compound twice, and that would be called semi-annually, or maybe twice a year, annually, double L. If n is 4, we'd compound 4 times, so that would be called quarterly. We'd compound quarterly. If n is 12, that would be number of times, 12 in a year, and that would be monthly. We're compounding monthly. If n is, let's see, well, the last one we'd talk about would be yearly. Or daily. Daily. If we're compounding daily, then how many times do we compound? Well, it depends. Usually, with a good bank, you would compound 365 times in a year because there are 365 days in a year. I don't think they would ever compound 366 times for a leap year. I think they would just simply say that 365 is just in general the number of days that we've got. Some banks and some books say that, well, the number of days in a year is 360 based on 12 months times 30 days in a month. And the way they do this, 30 just to make it easy on them and say, well, there's 30 days in a month, just to make it consistent with every single month that we can have. It's just 30 days in a month, whether there's 38, whether there's 31 or 30 or 28 based on February. But this makes it easy for them, and this also makes it cheaper for them because they don't compound as many times. So in this book that we're using, we use for daily compounding, we use n equals 365. So that's basically what the compound interest formula means and what the variables mean as well.